Welcome all. I see there's a couple of people still just piling in. We might just give it another 30 seconds before we kick off. Be with me, team. Everyone see TG slide that's just come up?
Yeah.
It looks fine. Okay, excellent. Look, welcome team to TG Risk's final webinar of the year. Getting pretty close to Christmas. I appreciate everybody who's taking out a little bit of time from their lunch today to attend this. Really appreciate it. Had some really good feedback on it, and just in general for our webinars that we've had over the year, it's something that we'll definitely be doing probably every couple of months going forward as a business as usual thing for us. When we held the equivalent of this webinar last year, so just before Christmas last year, I was chatting to one of the attendees who jumped on at the end. We had a conversation, said, I'll be looking if we could do a case study in one of the webinars. That would always be really good. So here, 12 months on from that feedback, really pleased to be able to offer this case study, which I've tried to make it sort of informal, and we're actually going to hear from someone who's on the end user side of things. So what's the webinar about? It's around safety and design, a case study for Project Basalt, which was Winstone Wallboards' new plasterboard factory that was built in Tauranga, which is just outside sort of Tauranga there. So a really sort of significant, greenfield plant. You can see there, you can just see some of the scale with the cars down the bottom left-hand corner. I have got a YouTube video. Let me, I'm going to bring that up. Show you guys so you can get a bit of a flyby. Hang on a moment.
I just talked to the name there, Hamish. So Project Basalt. Sure. Originally, this project was going to be in Auckland, and the rock of the area was basalt. So hence the name Project Basalt. When it moved to Tauranga, the rock was different, but no one had changed the name because it had already been embedded in all the language. So
yeah. Okay. Let's get a full screen. Just to share the. So that was just to give you a bit of a, I guess, a run through on that facility. and you've heard from him already, but I thought I would just do a quick intro for Shaun. So, and very grateful to have him come along and sort of speak from, I guess, the end user or the operator's perspective. And Shaun Sanders is the engineering manager at the Winstone Wallboards Tauranga plant, and he was the electrical and equipment safety lead for Project Basalt, which is what we're talking about. He's got an electrical and automation background, prior work experience with NZ Controls doing automation, amongst other things, and he's also held certifications in hazardous areas. I believe you were designing maybe biogas plants, if I recall correctly, Shaun.
Yeah.
And also doing a lot of work on machine safety as well. So, yeah, I think, we're going to talk about this project and the timeline, but it was a project that ran for multiple years. It also ran through COVID, which, as you can imagine, can introduce a whole bunch of supply chain issues, and you would need to have real resilience and the ability to turn the handle and keep going on that. So, and I think that's sort of well demonstrated by the fact that I think he's got at least one Ironman under his belt, possibly more. And just for giggles, he's currently doing an MBA at the moment, so not exactly an active relaxer. But we can see there from his experience and some of those personality attributes, he certainly knew what good looked like. I think we do some of the reflections at the end. Maybe we'll sort of see that was a key part of it. Just got a few more people I'm going to let in. Team, sorry, back there.
A breakdown at the moment, Hamish.
Do you want to give us a run through on the facility, Shaun, just to run us through, what happens there, how big it is, and just to sort of give us an overview on that?
Yeah. So thanks, Hamish. Just some key numbers there. We manufacture plasterboard up to 90 meters a minute. Depending on the thickness, we go slower. We also have a joints and finishing plant on site, which is all your compounds. We have about 130 staff on site. That's manufacturing, distribution, and all the support staff. You would have seen in the video, we have a big gypsum shed. We bring about 25,000 tonnes every 6 weeks out of Australia. The main building is a nice 50,000 square meters and about 450 meters long. But total roof coverage on site of the 13 hectares is 7 hectares, which is substantial. And we chose Gyptec out of North America to supply a turnkey project. There was probably only 2 vendors in the world that could supply it, and we did some early projects with both vendors to see which one fitted with us best, and Gyptec was what we landed on.
Yep, and probably just to touch on sort of Gyptec as well. They supply globally, so into Europe and North America. So while they're, I guess, North American headquartered, they certainly had experience with the European standards, which align with the Australian and New Zealand standards, which was helpful, and on the whole, actually very, very good engineers.
Yes.
Do you want to take? Yeah, sorry, Shaun. I'll maybe jump in, Shaun, at any point. Yeah.
No, and you can see from the timeline there, and we only started, we started in 2018. The reality is the project really started probably, 2010, when it was identified the capacity constraints that were coming into the Auckland plant. And then we did 2 projects in our Auckland plant to select our final vendor. So 2018 was really kicked off. That was when the project team was formed. And it's when we engaged TEG actually to help us write some of our foundation documents around safety. And we spent a good, 2 years. Hamish will attend to this. He was involved heavily doing HAZOPs and MRAs every week. Construction began in 2020. And that was when the site was finally formed and handed over to us. 21, the first bit of equipment went in. End of 22 was our first gypsum shipment prior to Christmas. And that was effectively when commissioning started. And I got there May 18 was the first board off the line. So Yeah, and one day we started at 7 a.m. in the morning, and I think it was around 8 at night we finally had the first board through. So very big day, and very successful from to start up a plant on its first day and run product. It was fantastic.
Yep. And I think probably a key thing to sort of take out of that, as Shaun sort of touched on, was we did get involved with Winstone Wallboards on some foundational documents way back when, and you look at it, there's 5 years there before the board came off. So this is a greenfield plant, and you could argue that perhaps it's easier to get things right on safety. I think it also makes the standards higher as well in terms of, and you could be a little bit more ambitious. But the safety and design process is something that has basically run its course for 5 years. So that's probably a key takeout. A key takeout of that project is that it was started early. That would be a key takeout. Certainly one of my reflections that I'll sort of recap on. But just in that sort of, I guess, that flavour or themes of foundation. When we think about this, Shaun, what would you say, were your safety objectives for this project? Why was safety and design so considered and something that you guys, clearly dedicated resources to? And maybe if you could share with us a little bit around, what was planned for, to do what and when and by who to sort of meet those.
Yeah, I mean, this was the largest investment in Fletcher Construction's history internally, at around $400 million of capital investment, plus all the rest of the cost of relocating an entire production facility. And so it was at the start. It was, we can't invest all this money and then hurt someone, right? So we had the opportunity from the very start to make sure that when we finished the project and delivered it back to the business, it was as safe as we could make it, as fully compliant, that we would operate for the next 50 years, which is what our other plants have ran for, 50 or 60 years. So the objective is to meet all the current standards, even meet future standards, the ones that we sort of knew were on the horizon. And it was really around making sure that everyone could go at the end of the day, and we could sleep easy at night as well.
Yep. And that was really, really evident, that leadership and commitment. What were, if you think about when you were at the beginning of the project and you formed that project team, what were, just at a high sort of timeline or process level, what were some of the key things that you decided to set up or allow for? I certainly know a couple of things that, I'm probably going to talk about because I thought they were foundational and they had a huge impact, but I'd be interested in your thoughts on that.
Yeah, so it's interesting, we engaged with TEG very early to write we call it Appendix A of our contract, that it went to all equipment suppliers had to sign up to the same contract terms. And that, it was Appendix A for a reason, that was about safety. So we said early on that this is key non-negotiables. So we spent a lot of time writing a very prescriptive document, using the standards, highlighting the exact steps we're going to take through the process, when, where, who, and how. And that really led through the whole design phase. It was always referring back to that document. What did that document say? So we put in place that we want a category 3 performance level D as a minimum, regardless of what the risk assessment said. And I remember many conversations, Hamish, and you probably had many with the vendors as well on the sideline saying, well, the risk assessment says we don't need that. Can we just try and get something less than? And we said, no, this is the minimum across our entire site. And yeah, it required some very strong leadership at a senior level. And so I credit Stuart and the governance team for holding stead on that with our contracts, because when it comes end of the day, it all costs money. And you've got vendors saying, well, we can do it a bit cheaper if we just take this out of our contract. So very strong leadership from the start is to say, yep, this is our minimums.
And I think probably on that Appendix A, or maybe just to expand on that and give people a little bit of information around it. So you could have a contract and you say the plan is to comply with ANZS 4024. You know, it can be grey. There's multiple standards that come out of it, and you can often end up in a situation where a vendor says, well, we think it complies, and the end user says, well, we don't. Residual risk can be one of those things. You might have two levels of residual risk that conceivably there could be an argument that it complies. And I think what was done well, because this plant was to a large degree being based off what they had in Auckland, Winstone Wallboards were able, and us working with them, were able to create Appendix A out of understanding what residual risks we could drill down to and set those expectations and be explicit. And so another example is, AS 4024 doesn't talk about, what safety solutions you use for whole body entry, where you walk inside large caged enclosures, and you may have seen some of those things in the video there. We got specific and said there will be an RFID or trap key type system for any whole body entry points, so that wasn't something that came up for debate down the line. There were Fletcher Building had policy requirements around process safety and HAZOPs and what needed to be done, and they were put into the contract that these things would be done. Likewise, machine risk assessments. The building of the plant, couldn't be done until the design was signed off, which couldn't be done until the machine risk assessment had been completed and approved. So all of these things were put into the contract, and it was always referred back to. And all of those discussions that you have throughout a project, they were resolved in minutes, because if it was explicitly covered in the contract, hey, look, we were going to go and do it, and if it wasn't, well, maybe that was a commercial decision for the governance team to comment on. Yeah, by all means, guys, if you do want to add some questions, there was a webinar form that came out. We've had a couple come in, one from Sarah, one from Smoothie. We'll get to your questions later on. I think at the end we've a little bit of time for that. But if others have got questions they want to raise, chuck them in the chat or the Q&A, and if you've got access to that, we'll try and get to those at the end. Moving on. So that was on program setup. Oops. So we looked at the, we talked about Appendix A, which is part of the contract that we talked about. And I guess, pre-contract, you would have gone through, you tested out your two vendors. That's something you've already talked about in terms of some smaller projects on site, so that you could pick the right vendor. But what was some of the, I guess, the design aspects, or the things that considered safety that you were doing even before you got to contract phase? And the reason why I say that is often, TEG's experience, but it's thankfully happening less and less, is often we get involved right at the very end of a project, so not even after the contract's been signed, but after it's sort of been commissioned, sort of thing. So, but there was safety being considered even before the contract had been signed, in terms of coming up with the overall sort of, I guess, specification and layouts. Do you want to take us through some of the things that were considered, Shaun?
Yeah, absolutely. And you're right. It's generally after the contract's been signed, people worry about it. So we spent months with the vendor. The key thing is seismic consideration on our site. They'd done projects in California and that, so they were like, yeah, that's not a problem. But as they found out, it was an issue. But we spent a lot of time. We spent months in, I guess, our develop design stage, looking at safety and how we're going to integrate that and what impact that would have on the vendor's standard equipment that they'd sell. They've sold us equipment. They've sold it into Australia, into Europe. So they're aware of all the standards, and you would have seen in the video, there's our paper handling machine. That one's fully guarded, and they've sold these into Australia and Europe and not guarded them either, because we hadn't been explicit in the contract as to, you will use this standard in this process. So yes, it definitely pushed up the final contract figure, and I think that was one thing GibTech were kind of mindful of, is that they'd sold into countries with the same standards, but probably hadn't had the rigor, and applied some more time to go through We looked at other parts. You know, one area that's quite interesting is our wet sampling area, where we sample our product. You know, the line's traveling at 90 meters a minute, but by the time it gets to that end, it could be accelerating up to over 200 meters a minute to try and pull a gap between boards. And we've got to take a little sample that's a meter long and safely and protect our people. So they had to design a whole new way of sampling product to meet the standards. So from an engineering point of view, I think a lot of things that were done by GibTech that I've never done before and probably maybe sell now. Probably, I guess the key was early on, how do you isolate a plant of this scale? You know, the board plant alone, we feed it with 10 transformers, so a significant amount of power across multiple switch rooms, you know, 600 odd drives, thousands of valves. So how do you isolate a plant safely and quickly without getting it wrong? And we made the decision early on that we didn't want just anyone walking into a switch room and turning stuff off, even though, you know, cabinets are all safe, but that becomes risky. So the challenge is how do we isolate outside the switch rooms? Can we just have giant isolators? Which you can, and that was actually where we were going down the track. We were going to mimic our distribution boards outside disconnects and have large valve disconnects and large electrical isolators, so you could isolate there. You could isolate large parts of the plant. But then is there a better way? So we set about trying to design a remote isolation system, which is done quite a lot in Australia on the HV conveyors. Not really done in New Zealand, to my knowledge. So we set about designing that with GibTech. How can we isolate large portions of plant with a push button? And we successfully made it. And we can isolate gas, pneumatics, electricity, any energy source in a particular area is done with a push button. So we wrote the documents, we sent it to companies like TEG, some other consulting firms, and said, are we meeting the standards? You know, not only electrical, but machine safety. There was quite a lot to consider. You know, we've just changed our electrical standards in New Zealand, you know, this year to 2018. Under the original standards, we could isolate with the PLC. The new standard says you cannot isolate with the PLC. We knew that the standard was going to come in, so we had to get ahead of that. We took all the recommendations from TEG and some other consulting firms, and even though they said what we'd built and designed was going to be compliant, these are recommendations. So we took every recommendation and put them into the system, just to guarantee it. Did it cost us some money? Yeah, it cost us about $1 million to implement. But we have now 40 locations on site that isolate areas. The area is isolated correctly, up and downstream equipment is taken care of. And it just means we can isolate large-scale plant in minutes rather than hours.
And so the really big, I guess, positive outcome for that is you just reduce the risk of error in isolation, but not just that, you don't make isolation a time-consuming problem that might mean that people are behaviourally inclined to avoid doing it when they should do it. So I know one experience I had, I sat down and I spoke with you and Robert Steele, your process specialist, and we talked about hazardous areas and dust clouds, and we gave conservative zones for you, and you actually formed your layout on the basis of those zones. So you said, well, if we, you know, place this plant here and we place this plant here and we do this, then actually we can reduce the amount of electrical compliance and number of ignition sources that will sit inside. So that front-end design work, I think, you know, pre-contract, you know, had a really, really profound impact on the project, and absolutely was very much worthwhile.
Yeah.
Going up, I guess then just sort of running through, you know, contract signed, you move into design and build phase, which I think in the timeline was 2020. We jumped into thing. What sort of processes were carried out to ensure safety? Like you touched on them previously. I mean, I'll start with HAZOPs. I think when we started the HAZOPs, we were about maybe 2 weeks into lockdown. I can't recall, Shaun. It was something like that. I think Shaun was head decamped to his batch on the Coromandel, so he was on a Zoom call for our online HAZOPs from there. But yeah, I think if do you want to run us through the different processes that we did throughout there that were part of the design, I guess, gates or safety and design sort of steps?
Yeah, absolutely. I mean, HAZOPs can be challenging in the best of times, so we'd always envisaged that the first few HAZOPs would do face-to-face, either in New Zealand or North America, but we had to start off remotely. And so we would spend, I think we'd do two-hour sessions a week on HAZOPs and 1 or 2 a week on risk assessment for each area of the plant. And they were all staged in the criticality of build as well, Yes, it took a long time to assemble it on site, but you still had to manufacture all this equipment offshore and bring it in as well. So, and yeah, nothing really went to build until the risk assessments and HAZOPs were signed off, which is a key thing. And that put some nice time pressure on. Means that people couldn't just delay doing this to later because we wouldn't agree to contract terms or make payments until this had been done. And it did keep that ball rolling really well.
Yep, and that's a big part of that was because it was tied up in Appendix A. We won't commit to build until the machine risk assessment's been signed off. What were some of the successes that came out of that? I know the tipple was one for me. That was a re-engineering. So that Fletcher Building, you cannot work. They've got a critical life-saving rule where you cannot be under a suspended load. And the current design from GipTech, there was one part of the plant which required some sort of access or egress under a suspended load under certain conditions, and we went away we didn't. GipTech went away and re-engineered that and eliminated that particular hazard. I think you mentioned the QA board. Any other particular wins that you recall coming out of those sessions, Shaun?
Yeah, I mean, our wet waste bunker is another key one as well, Hamish. For people that may have seen our plant or know about it, we produce this board in a continuous length, and if it doesn't go right, we chop it up at the end. Some plants just fire it into a concrete wall. Some plants just fire it off a cliff and deal with it later. So that was the key for us: is how do we deal with this wet waste? And if it's coming at you at a couple hundred meters a minute and it's a full sheet, you've got some serious force behind it. So a lot of challenges around how we, light curtains, dusty, can't use that. Laser scanners, same thing, too much dust. So eventually we ended up with radar. And that came with different challenges because radar isn't as flat as light, so a lot of work went on in that space. There was a lot of design work around how we could run our plant with that. And a good thing, right? It challenges the current thinking and you come up with better ways to do things.
Yeah, and that's probably, a good sort of lead in, you think about it. That's a success, I guess, in terms of challenge people to innovate and come up with new ideas. Perhaps there were solutions that GipTech are now reselling to others. I don't know, I'd have to check that. I certainly think there were some improved designs. So there's some great successes. What do you think, I guess, shouldn't all be, I'm sure there's things that didn't go according to plan. What would you do differently next time, I guess, through all of those processes?
Yeah, it's probably having more resources to review outcomes of the HAZOPs and MRAs, right? So we would do it, then we're taken on board, they'll go away and design something to fit. And it was then the time pressures to try and review those and improve those was the real challenge. So yeah, I think next time we would probably have a larger project team. There was only 4 of us on the Winstone side that were trying to not only do a machine but design a building as well.
Yeah,
remember this is
heroic for 4 people. That sounds heroic.
It was ridiculous, right? I mean, we had some great consultants like TEG, and we had all these consultants in the building space. But it's having the time to review all the little details, and we missed out. We missed some stuff which we had to pick up in commissioning, and so did GipTech. I think and it wasn't until we got through certain parts and we're like, hang on, did this really meet the design intent? What were we actually trying to achieve there? Did we go too far or not far enough? So Yeah, next time would definitely be having more people involved, just in that review process once you've got through detailed design. And I think the big key success, and GibTech were not a fan of the isolation system at the start, to the point they actually refused to use it because they determined it was unsafe. But once we'd actually been through the process with TEG and Charles, he was here for many days validating it, right? We wrote such a stringent validation regime of how we test it, just trying to think of every single way a human could get around it. And once we had it and we tested it and we could not get it to fail, I think GibTech actually thought, this is actually a pretty slick selling idea. So I wouldn't be surprised if they sell it in different parts of the world now. But I can't comment on that.
Yeah. So through design of build, obviously we get to a point of commissioning and sort of handover. And one thing I was sort of moving on to that phase there, that staged risk assessment review approval process means a lot of verification was actually happening throughout the project. So that was really, really good. But in terms of some of the stuff that was also done, as that commissioning process was done, as built verification to make sure that it had been built right. I mean, it's a massive plant. You can do your risk assessment, you can specify it, and it's to be expected the odd thing might be missed. So we went through, we captured that. I'm going to skip down to functional safety validation. So Charles, who's our sort of leading guru in TEG on functional safety, he did a count up and he reckons there was 15,000 individual safety functions across the entire plant that went through validation. And that had to be done under pretty strict timeframes before the plant could be handed over to Winstone Wallboards. So, great effort from him and working with GibTech to move through that, with a really robust sort of validation plan of design and analysis to get that done. So that seemed to go really, really well. And then probably on that end user safety information piece, I think that was something also that showed a bit of leadership, because I think Stuart Vaughan, who was sort of program director, I can't recall his exact title, he knew that safety wasn't just, we've got a safe plant and that's it, we're done and forget about it. We've actually got end user information that we need to supply. And so information like, hazard overview cards and lockout, tag out procedures and also need to be prepared. And something that TEG was able to do was utilize our min risk application. So we did that and captured snag lists where things were missed. It also gave Winstone Wallboards a tool so they could go in and update records when things were addressed, and also reference photos. Hey, this is handover day. This is what the plant looked like, or it's now compliant. This is what it looks like. And proper compliant risk assessments too. So there's good conformity there with compliance with the regulations around that. And there's just some sample risk assessments that were all done as a part of closing the loop on that verification. But probably this is one here that was a bit of a highlight, because we were challenged. I think Shaun's touched on it previously, that the timeline challenged people, us, through the risk assessment process, pushing back on certain risks, challenged GibTech, it challenged Winstone Wallboards. And there was a challenge put to us by Stuart Vaughan. He sort of said, look, we need something simple that shows this is the lockout tag out plan for this plant, and these are the hazards, and this is how you keep yourself safe. And so as a part of the project, we actually worked with Minris to develop an application read-only that presented that information. So we end up with these hazard overview cards. So all that information's there, accessible on mobile devices. It's QR codable, although we've just got asset numbers, asset tags that they refer to, and also a lockout tag out plans as well. So going off to the isolation sort of solution that Shaun mentioned. So, it was all encompassing. It wasn't just great, we've got the plan, it's fully compliant, that's it, we forget about safety. They were thinking about the future, which again, I think is a sign that, Winstone Wallboards knew what good looked like, which was a key takeaway for me, and resourced it accordingly. But Shaun, I'm sort of conscious of the fact we want to give a little bit of time for questions at the end. What are your sort of reflections? How do you feel about the project when you look back? What are the keys for safety success that others, can take on board? If you had to do it again, what would you do the same or differently?
Yeah, I mean, I look back on it, it's actually a bit of a blur, to be honest. It was a large part of my life. My wife probably didn't enjoy all of it. But fantastic to be able to be part of such a large project. We just don't have a lot of these in New Zealand, so it was, as soon as I got the opportunity, I jumped at it. The key to success, and hand on heart, we've got the safest plant in New Zealand, I believe, and we have had no injuries from the machine, which is fantastic. We produce a lot of product. We have a lot of people. We have a lot of contractors that come through the place, and we know that even humans, being humans, will generally do what they like. We know that our people and our visitors are protected. This has become a major tourist route lately, with everyone wanting to come and see the plant. So, I can hand on heart say that even if people are being silly, they're not going to hurt themselves. There's enough protection in place. So I think that's definitely a key success. And, for everyone else watching and listening to this, is start the journey early. Like, the earlier you can start this, the better it's going to be, and it's going to save you money. At the end of the day, trying to retrofit safety into plant can be very expensive. And generally you shoehorn in a solution that's not fit for purpose because the mechanics don't allow for it, right? Whereas we separated conveyors, we put other stage gates into the mechanical design to allow for those 15,000 safety functions to work.
Yep.
Yeah, that's probably it. Start early.
Okay. Yeah. I know certainly for me, I look back and I think the leadership was the foundation. That assured that not only did the safety and design happen early, but you stayed the course. And I think it was really good engineering leadership. So Stuart Vaughan, who was the program director, and Shaun are both safety-minded engineers. But I think because of that, because they were engineers and it wasn't just given to a safety person as well, it meant that it was integrated into the overall project. So that was really, really, effective. It meant that the engineers were sort of dialed into it. I reiterate your point around safety and design starts early. I don't think we can underestimate the technical competency side of things. So Shaun is very strong in safety and machine safety and hazardous areas. So he knew what good looked like from a technical standpoint. Stuart knew what good looked like from a health and safety management standpoint. And GipTech, I thought, were actually really competent engineers. They were, challenged on a couple of things and came away with some really good designs too. So that technical competency, I think, was really important. And I think because Appendix A had good process baked into it, you followed the process and sort of the outcomes kind of took care of themselves. So Appendix A was extremely foundational because it had all of that process stuff sort of baked into it. So yeah, look, I sort of touched on it at the beginning. It's very much a project that we're proud to be a part of because we normally don't get brought in so early, so we don't get to contribute it in the same way that we did. So yeah, we're immensely proud to be a part of it. And I know sort of Charles was pretty chuffed with going through his validation on 15,000 assets. We had KC doing all the verification as well, going around on things. So and with that application development we did for lotto cards, like there's heaps there that we love. But we've got 5 minutes left for Q&A. Now, we did have a couple of questions that came through. One of the questions we've got is from Sarah. And it was there any consideration of worker ergonomics and occupational hygiene risks, such as dust, noise, or vibration exposure? And were workers consulted on these risks, and how were they, like to be engineered out through the design phase? Did you want to touch on that, Shaun? I can add to it.
Yeah, great question, And it was quite interesting. One of the mechanical engineers, Paul from GipTech, he is 6'7" or 6'8" tall. And I'm a very short man, so we used to quite often talk about hobbits and orcs. Can a tall person and a short person both work on the same machine? So in some areas we had steps that were able to be hinged out of the road to accommodate different heights of people. We wanted the plant to be no hearing protection required throughout the entire plant, which is hard to do, right? And so, you know, part of one of our other appendices was we imposed an 80 decibel noise limit within inside the factory. That was driven by us not wanting to wear hearing protection, but also we had a very tight boundary limit. So we did that. We've ended up with hearing protection just because there's a couple of little areas where try as they might, they could not get those noise levels down. But it's still a very, Hamish, you've been in the factory, and people that have, is you can have a conversation anywhere inside the plant generally, quite comfortably. So that's really good. Dust, again, huge consideration. We put a lot of effort into making sure dust collection was done right. You know, we've got a lot of combustible dust, so we need to manage those. And just from that health and safety risk, because we don't want to expose our people to anything. We random quite often we'll put monitors on staff for a few weeks. They'll walk around measuring, you know, ambient noises, dust limits and things like that. So a lot of effort went in up front to try and, from that ergonomics and people point of view. We also had a lot of reviews with production staff out of our Auckland plant. So every time we had a new part of the plant from the vendor available with drawings and 3D models, we'd be walking them through it, asking them, what do you think? What have we missed? You know, because we're very much engineer focused. We wanted to see what our people thought about layouts. How could we get forklifts in? How could we get people in? So that was all built into the early stages as well.
Great. Next question is from Smruthy, who said, were there any instances of a safety requirement or control measure that sounded great in theory, but was tough to practically implement and you needed an innovative workaround? If so, can you provide an example or what you did?
Yeah, I think I touched on it earlier, was that paper handling system, right? You know, I think you were, you know, instrumental in that, Hamish, with providing us the standards to really follow on, you know, it's the gaps between parts, whereas everywhere else in the world they wouldn't guard this thing. So that was a huge challenge for the vendor. And one of the biggest challenges is how do you thread this machine up? Because before you'd be in there and you'd have it live and you'd be able to move things around and get paper through. So it was, you know, let's look at the paper industry. You know, paper machines that are huge machines, they have thread up ropes and modes. So that was a challenge that the vendor had to overcome, and they did a reasonable job in overcoming that and coming up with a system where we don't have to be in there while the machine's live and active. We can set it up and it can thread the machine itself. So that was a good innovation there.
Yep. Cool. Okay. And we've got a question here from Alton. What do you think the typical biggest risk in a gypsum board manufacturing plant is from accident records? Yeah, gives examples: conveyor safety, dust explosion, yeah, those sorts of things. So I don't know what you know from, you know, plasterboard plants around the world, but I know obviously bulk material handling conveyors are highly hazardous.
I was going to say humans, right? They're the most hazardous thing out there. Yeah, I mean, yeah, conveyors definitely are. And so we put a lot of effort into making sure our conveyors are compliant. You know, yes, you're allowed to, under the standards, you know, touch bulk handling conveyors, but as a rule, we've generally isolated them from the plant. Lots of gates went in. You know, I know Rockwell would have loved us for the amount of gating blocks we used, but we've got gates everywhere, and we've put more in since we even commissioned the plant. And it means that we don't have to take guards off. We don't actually have to isolate, and you can get into plant in seconds as long as the machine stops. So yeah, the bulk handling conveyors is probably the key, and forklifts. So you know, we can't do a lot about those at this stage, but that's probably our next biggest focus.
Yeah, I think it's a really good point. You talk about adding in gates. You know, it doesn't stop you know, safety doesn't stop the day the project gets handed over from the vendor. You know, risk assessment. You know, risk assessment should be a live document. Should be reviewing things and looking to optimize. So. Yeah, that's a really good point. I noticed we've just hit 12:45. It was a 45-minute slot. I'm conscious people probably want to get back to their day jobs. I just want to round out by saying a big thank you to Shaun at Winstone Wallboards for sharing his time and his experiences. It was great that we could share a case study like the feedback we got this time last year. So thank you, Shaun, for that. Hopefully, all of our listeners out there have gotten something useful out of that. For all of those that have registered, even if you couldn't attend, I think some gym people were going to attend but couldn't because of a breakdown, then you will be able to download the slides and the discussion and so forth from the webinar link, even if you didn't attend this. So with that, last thing I'll say is we'll come back with more webinars next year. We'll have a program every 2 months. We'd love to see you. They've been really well received. Thanks for your feedback. We welcome any ideas, suggestions from you guys as well. And then finally, I just want to say you guys have a really good, safe Christmas. Yeah, look forward to seeing you guys in the new year. Thanks again, Shaun. Hopefully you get up to the Coromandel and get some fishing in this this Christmas in between NBAs and things like that.
Try my best.
All good. Wonderful. Thanks, team.
Thanks a lot.
Have a good Christmas. Cheers.
Yes, bye.